project and then click next. Then you will select the project path and keep this template project path empty. You can set temporary project or in progress, the user like a single user, read only or read and write. You must select read and write. The unit system is undefined and click next. This is the database option, the studio, we don't need that, so we will click next. So here we go, the new project was created. So let's finish this and replace the current window, and here we go. You see there is a new project, the project name SGS training. So let me introduce you to the user interface. This is the main interface of the Techlog. There's a multiple tab, like first tab is a project, where you have new project. You can open the previous project, you can save the project, close the project, you can open the recent project, import, export, the different utilities. Okay, like project information and different thing, the license, the print, the options. The second tab is a home tab, where you can see the save button, the import data button, the export, the print, the window screenshot, and many other options. The next is the plot, where you have the windows option like log views, cross plots, line plots, histogram, etc. This was used to plot the log data. The next is the data option, like data editor, zone editor. You can variable splicing, resampling tool, and different tools. Like next is the utility, then studio, and then there is a petrophysics. This is the main tab we are going to use in this course. The next is geology, the geometry, geomechanics, drilling, weather wire, geophysics, unconventional, and shale suit. So in this course we are going to use home tab, plot, data, and the petrophysics. Okay. Now we need some windows here, like we right click on that, or we need the dock windows. There is an option, you click on the home, then here you have dock windows, click on that. We need the project browser. Okay, go here and you can see there's the option dataset, layout, cross plots, the wells, the layout. Okay, there's option you can hide this window, like you fix this window, or you can hide this like this, and you can hide at current position, you can hide at left, right, or bottom, anywhere you want. Okay, the next we want the property, so click on that, it will come there. There's nothing selected, so no properties here. And the third, we want the zonation. So these are the main tabs we want for our project to work. Okay, let's start by importing the well data. So to import the data, you have to go to the home page and you have to click import. So the import tab is now active. So for data import, you have to go to the project browser, and here is the import window, the file import. So you have to click on this folder button to open our file. So let me click on that, then go to our data. Now I'm gonna open our LAS file, the well log LAS file. Just click on there, click open. So let's see, let's ignore this error. Let me pin this window. Now it will not hide. So let's see the logs. Here are all the logs. So let's move this log into our project by selecting this and import. So here you see the data set is here. Okay, let's delete this from import and close this. Okay, now we have to check our logs and their units. This is the most important step. Okay, for that the first we have depth, it's in meter. We have a caliber log, is inches. Oh, let me introduce the logs with a small introduction. Like caliper log is used for the whole diameter, the whole shape. It will show us how our well hole is the hole is tight or it's having caving or enlarged hole. This log will tell us about that. There's another cali. Then we have a CGR, the camera minus uranium. So in the camera its units are API, but here you can see it's unknown. So we have to correct this unit. So click on that, then go to property. First check the project if there is a CGR. Okay, first we have to again wait a second. We have to select this, property, we have to select this, and let me select the F4 and our property is here. Let me put this in here. Okay, now when I select the CGR, you can see here is a gamma ray, the gamma ray minus uranium, the unit is unknown. So we have to select the unit, the GAPI, and here you can see its unit changed. Okay, the next, the D row is gram per centimeter cube. The D row is a density correction. Okay, then again we have a DT, it's a sonic log. The next we have a GR, the gamma ray log. We have to again, its API unit and the family unit are GAPI or API, both are same, but let's say we have CGR in GAPI, so again we change the GR into GAPI. Okay, then we have a LLD, the deep resistivity, the formation resistivity, it also called the formation resistivity, is ohm meter is okay. Then the shallow resistivity, this is mostly the mud resistivity, is okay. Then MSFL, micro resistivity, and then we have a neutron porosity, V by V decimal is okay. Then we have a PEF log, the photoelectric factor, it's okay. Then we have a density, the bulk density gram per centimeter cube is fine. And then we have a SP log, it's a milliwatt. So all the units are corrected. So let's again move this, hide it to this to the left side, is again come to there. So let's display our logs. For displaying, we have to go to the plot and we click the log view, and here is the log view. Just click on the box to maximize the window, and now we have to plot our log. The Techlog is very easy and simple to display the log. So like I first want to display the caliber, so let me click on that, and here you can see the caliber log. Okay, let's zoom this out a little bit. For that you have to click the middle mouse button and just move the mouse up and down to zoom in and zoom out. So this is okay for me. So now next I'm going to put GR into this track. Here we go. There is our GR with the baseline set to 75. We can move this according to our requirement, or we can delete this. Here you can see we need only GR. Here you can see we can stretch squeeze the log by control and mouse scroll. You see, here you can see we also this, then expand with control plus mouse scroll, and the whole window zoom, you just have to press the mouse scroll, zoom in, zoom out by just moving the mouse up and down. Okay, now next I will put SP log into first track. Okay, now in this second track we will display the resistivity logs. So first let's drop the LLD, then LLS, and then MSFL. Okay, there is a difference. The LLS must be in blue color and LLD must be red. So we click on the LLD, we go into properties, and we will go into display options. In the color type, color mode, then we select the color and we click on the red and click OK, and here we go, our LLD in red color. Now we have to change the LLS to blue. So again go to property, display option, click blue, click OK. Our recorder screen pops up, so don't worry. Let's move this out, and now here you can see. Now see, let me stretch this out, and here you go. Here we are. Okay, that's great. Okay, now next we drop the row B here, and then we select the N5, the neutron prosody there, and now we have to check out the we have to drop the crossover of a neutron density. For that we have to click on N5 curve, then press control and then select the row B curve, and then right click, and there is option the insert area fill between the variables. So let's click on that, and here you can see it fills the curves between them. The yellow will show our porous zone, and this is a non-porous. So if you want to see only the porous zone, so you just have to select this, click on this fill, then go to properties, then there we have option bicolor or single color, or we can set the palettes. So I will say only left, so it will remove all the other color. Like you can see now only the yellow fill. It engaged the yellow area. The neutron density crossover will show us the porous zone. Like you can see the zone of interest. Okay, let's create. Now again the D row, it will also be in that area. So let's remove its fill, and now in the last we have to display the DT log, sonic, and we have a path log. Again, let's display the fill. Let's remove its fill. So just simply select and select and delete, and here we go. Okay, now all our curves are in the log view. So here you can see we created our template, a log template. Here we have all the parameters. So now there is a question how to change these scales of the logs. Like I want to change the DT scale. If I want to change DT scale, so I will click on this DT curve, and I'll go to the property, and then there is the horizontal axis limit. It selected the family. By default it will be the family, and it will give all the scales to the curves that are used in the industry. If your log template is according to the log, like DT template is set to the compressional slowness, which is its property. So I can change this. If I want to change this, there is a two option. There is a variable option. It will change the DT value to the log curves value, like minimum DT value to the maximum DT value. Like if I click on that, here you can see the minimum is -87, the maximum 218. So it plot that DT curve to that range. Now if I want to be according to my own choice value, so I'll click on that. Like I'll say I want 42 140. So there you go, my DT will be plotted on according to that. So like that I can change any curves value. Like if GR, again property, there you can see its family is mostly in the industry we use the same value of 0 to 150, but we can also change that, like user, I'll say 0 to 200, so you can see it's changed. Again I'll let it go back to the family value. So like that you can change any curve's scale. Okay, the next thing, if you want to change the curve thickness, like I say the caliper thickness is too low, so I'll click on the curve. I'll again go to the property, go to the display property. So here you can see the line thickness. We can change the line type, like it's dotted. If I want to dashes, I click on that, it will change into dashes. If I want solid line, then it will change into a solid line. You see there's a solid line, but again I want this as a dotted line, that is by default. So I'll stick a dot. Now I'll change its thickness, like there you go. So 2, 3, 4, 5, any I want. So I'll again go to 1. Okay, and here you can see you can change any curve thickness and properties from the properties. Like there's a GR, I want to change the GR line color, so I'll go to display, is globally is that I want this to green, click on that, and here you will see the GR will turn green. Okay, again there is another option, is a baseline option. Like I want to see my whole condition and I want to set the baseline for the whole, and I will say the upper section is like say I'll say it's a the whole size is like I'll say 12.5 inch. Okay, then I'll select the curve and I'll say I'll set a vertical baseline for that. Now I'll check this, let me set like there. See, it filled this side and both of the side, and here you can see I'll say this is my bit size. Like let me move a little bit over. It's a 12/4 hole, 12.29. So this is my hole size. So on the right side it shows the hole enlargement, the caving. On the left side it shows the mud cake, the hole tighten. The mud cake is a good indication. It shows our zone is permeable. So here you can see it shows us there is our gauged hole, so no color. Again there's like mud cake, the smooth hole. Let's move down a little bit, and here you can see. Okay, so this is a way we can add a baseline. So now here you see a large mud cake, but this is not mud cake. At this position, like there about there, our hole size change is 8.5 inch hole at that location there. So we can change this from 8 there. So there you can see where hole is gauged is on the line, and where you have shale we see this caving, the hole enlargement. So that's the way we can set the baseline. So we can delete that. Just click on that, right click and delete, and here you can see it's removed. We can also set the same baseline for GR. So just click on the GR, go to insert vertical baseline, and for GR we will set that to 75, like it's 150, so the middle part will be the 75, like there. We click on that, and here you can see we can also change this pattern or the color from the properties, like there you can see the bike color. I must say from above 75 I'll wanna put the, there you can see the pattern. If I set the GR, it will change the color according to that. See, here you can see like that. There you can see. We can also change the palettes. We can also set the different palettes. For that we can also only color. We can set the pattern, like I say, if it's less than 75 and I want to set this as sandstone or any other thing, like me see that, like I say this bed. Oh. So you see, there we go. The same pattern will fill for this side. I want to set this for shale, so again I will select this, go to the property. On the left side we can search that SHALE, and there is the shale, a clay shale. So click on that. Oh, it's not filled. Let's again select that, click on that. Oh, I have to change this from pattern, and here we go. You can see if I change the baseline, it changed the, you see, the fill. If I change, go there, let's go to this. So it's really easy. We'll try this. Okay, let's delete this too. There's another option of curve filling. So let me select this and go to the variable. So we can set to lower limit or higher limit. Like let me set to the lower limit. I can select the simple color or the palette, any palette, or these palettes, the color palettes. Like I click these color and click on this. Now this filled up. Okay, now I want to change this color contrast, because it's only giving the one color, so I have to change the palette of this. So for that I have to set the palette. So right click on that, the dock window, and click palettes, and now click on the palette, and there is our palette. So you see there is an issue. The palette range is 0 from 80 and our log range is 0 to 150. So simply we have to select this color and we have to just set this to 150 and enter, and here you see now we can see the color variation according to that. You see there is a clean sand, it will show us the clean. We can also change this to get more clear view, like I shift this to 50 and this to 100. First I have to select this, then I select this to 50. See, this is the more clean, and then I'll select to 100, and then this is the more dark. And here you can see, but for this template is 0 to 150 is the good one. First we have to select this, then again 150 and 0, and here we go. So that's how you will set the template of the well logs in the Techlog. Okay, let's hide this, and there we go. The next thing is we have to build an harmonized data set that we will use for our interpretation. So for that we have to select our curves. So let me zoom a little bit. So I click on the curve 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have to select only curve, not these color fills. If we select this, the harmonized data set will not appear. So we have to see that we only select the variable curve. So that click on variable, click on harmonized data set and build a harmonized data set. So let's click on the build, and there will go the log QC, the LQC, and we click on the well name SGS1 and click OK. And here you can see there is a new data set in our project browser which contain only the logs we selected. So this is the data set we are going to use for our interpretation, the petrophysical interpretation. Okay, let me just briefly tell you what is the petrophysical interpretation workflow. So the first thing, we have to select the reservoir rock. So as we know, our reservoir either will be the clean sand or the limestone or dolomite. So for identifying that zone, that rock, like either is a sand or a limestone, the lithology indicator is a GR log. If GR values are low, like less than 70 or 50, is going toward the sand or the limestone, which is our reservoir. So first we check that. So like if we having the GR is greater than 75, we will not take that zone. If less than 75, we'll take the zone, like I'll say first, like I mark this zone from 650 to 700. because its GR is very low. We can see its value from here. You have see the display the value, and there is the display the position. So click there. So there you can see the values. So now we selected our rock from the whole package. Like we have a 200 or 300 meter package, and we selected that we have 100 meter of a clean sand from a GR log. The next step is how much part of this rock can act as a reservoir. For reservoir we need porosity and permeability. Then there we can use the density log and the neutron porosity or DT log to get the porosities. So when we get the porosities, we will make the cutoff. Like we want to get the reservoir log which having the porosity greater than 4% and less than 30% or something. That will be our cutoff. Then from that 100 meter, when we apply the porosity cutoff, the rock will remain from 100 to like I say the 50 meter. So that's our second step. First we identify the rock, the second we identify the reservoir. Now the last part will be we have to identify the pay zone, like which zone having the hydrocarbon. For that we will use the resistivity logs, like these is LLD, LLS. We'll look for high resistivity, like this zone is having a really high resistivity. I'm visually telling that. We will calculate this by using Techlog, and it will prove how much water saturation we have in that zone. So then we again place a cutoff of water saturation. Like I'll say if we having less than 50% water saturation, that zone will be our pay zone. So we'll apply that, and it will extract that zone from our reservoir. So we started from 200 meter thick reservoir or 200 meter thick package where we extracted a rock which can act as a reservoir. Then we incorporate of the porosities. The porosities we use. Okay, the porosities indicated that this is our reservoir, and then the water saturation show us this is our pay zone. This is all the workflow of petrophysical interpretation, and that will we do in this software. Okay, this is the first thing. Now let's so this is all about the layout. You all have to practice that because after that our next step is the petrophysical interpretation. So before going to interpretation, we have to compute few parameters before interpretation that are important for interpretation, that are called pre-computations in the Petrol. So first we have to save our layout. So we have to just go to save and save our layout as, let's say, SGS. Click OK. We are also save our layout of it's save. So we can minimize that. If you close that, it will close. We can find our layout in here. in the project browser. There's a dataset and there is a layout. Okay, now next step, let's move to the interpretation. For interpretation, we have to go to the petrophysics, like click on that, then where we have a quantity, just click on that. Now there we have a pre-computations, we have to click on that. Okay, one thing we miss, let's move back, that's the important thing. We haven't import the well top or zones, so for that again we have to maximize our layout and we have to go to home tab, we go to import, we go to open, there is our well top file, we click on this, open this, there is a data import wizard, so there is our data, this will be well name, the data set will be zonation, its depth and its name. Okay, so these are our data set is interval type, our data import from line 3 is just equal is line 3, the variable names are on 1 is good, the units are on 2, there is a 0, so that's why the units are not visible in this. So let's click on that and click 2 and let's preview, and here we go, let's pick up the unit. Okay, but everything else are by default, so we just click on load to import buffer, so we click on that and here you see there are SGS and there are zonations. So let's click on this and let's move it to our project. Here you can see the zonation added into our well, so let's delete this and close the import window, and let's add our the zones into the log view. So let's click on empty space, right click on that, and there is option insert a zonation track, so click on that. Now there is nothing in that because I haven't turned on any zone, so I go to zonation, let's click on zonation, there are our formations, so let's click on 0, this. Now every formation is turned on but it's in black color. Why? Because its color is black. So simply I click on that and we'll say automatic zone color definition, click on that and here you go, everything is visible now. I can change single zone color by right click on that and define the zone color, and we can change this from this. See, it's changed same to all formation because I selected all that. So let's again go to automatic. We can add the pattern, but now we also see the properties of this. Let's see, there are the properties. We can change the track thickness like this. We can change its units. Okay, there is the orientation like this. Again the zones. See, we can change this like that. You can do so many things in that. you can play with these settings. Okay, there's option, there's interval, we can turn on these top values. Display, we can change the colors. Like I say, I must want this in white, so they will be this. Again, let's change this to black, and here you can see this. Again, we can change this vertical or horizontal. We can center or left or right. Again, go to center. So we can change any type like this. Let's move again to normal. Again, there are so many settings we can do that. Like we can change bold to their size from 16, and here you can see there's so many properties we can play with that. So we can change the track, every track setting. Like I select this track, there is its width, we can change that. We can see there is a line count 4. I can increase that like these multiples. You can decrease, you can see there. We can increase the thickness of these lines, decrease that. We can change this linear, logarithmic, any, but as we know the density logs are linear in scale and the resistivity are in logarithmic, so it's by default in that. So we can turn off this color like zone color from there, like I uncheck that and it will remove that. Like for that I would select all and go to this and zone color, and here you can see all the zone color are visible. So that was missing, we added that. We can change that by simply, here we go, graphically added that by clicking on that. I say it's a little down, it will move this down. It's a little up, it will move this up. Okay, there is another method. We can go into data, we can go into zone editor. So it say please drop your well here, so I'll drop the well. Now I want to change any of this formation, so there it is. I click on this, I change this, and I can save this. If I want to add a new zone in there, I simply have to click on this, and there is add new zone. I can put the new name in there, and I can put the value, and it can show us. So currently I don't want, so I'll close that, and it is asking do you want to save. Currently I don't want to save it, so I click on no. So here is our layout. So I click on this, the multi-well layout, and save our layout, and then minimize that. Now let's move to the petrophysics. So petrophysics, like pre-computation, the first thing we want to calculate is formation temperature. So for that we could click on the formation temperature. So for that we have to use our LQC, so click on that and variables. Now it's saying it's need depth, so depth is MD, So I'll click on that and create. Click on create, and there is our workflow. So first thing, it will ask me to please drop your dataset here. So I'll select my LQC dataset, click on that and drag into there. The second is zonation. I want temperature from all zone, so there's all. Now it wants me to set the parameters. So for temperature, there's a two method. The gradient method, if I know the gradient, I can put that, or top logging interval or bottom logging interval. So I'll select the top logging interval and bottom logging interval. So I'll click on that. My top logging interval is 0 and my bottom logging interval is this 227836. So I'll put that 2278.366. Our units are meter. So now I have to give the top logging temperature. These temperatures are always mentioned in the well log headers, the last file. So I extracted from that. There is a parameter, so it's saying our surface temperature is, our top logging temperature is 74 degree Fahrenheit. So I'll move to there. I move this 74 and it's shown as a degree Fahrenheit, so I have to change this degree Fahrenheit. Okay, the next is bottom logging temperature. So our bottom logging temperature is 208. So I put at 208 and again is degree Fahrenheit. So now I have to display the temperature curve. So I have to display this, and here you can see. Let me begin then zoom out this, and let's see, there we go, our temperature is increasing with the depth. So let me change its property scale, like it's 0 to 60 degrees Celsius. Let it set to variable, like is up to 97 till bottom. So here you can see it's increasing with the depth, and it's degree Fahrenheit or degree Celsius. If I want to see in degree Celsius or degree Fahrenheit, I can change that from here. Like this is degree Fahrenheit, I change it to this, it will change it to degree Fahrenheit. It's really simple. Okay, let's close this. And this work layout, I don't want to save this. Now I want to save this curve, because this is correct curve. So simply click on save and run. I click on run, and there you can see in our data set the formation temperature is added. Okay, the next pre-computation is the most important one. Now we need the resistivity of water. There is a multiple method that we can calculate that. In mostly cases, the resistivity of water, the RWO, is present in the well log header, but if it's not available there, we can calculate that. there are multiple method. The one is very simplest method. You just see your logs and find out the cleanest sand in that. When you see the cleanest sand zone, then check there. At that zone you have to check the shallow resistivity, and that value of the resistivity is your resistivity of water, or W. One is this. The second method is you can use temperature and SP log and RMF values, the resistivity of one filtrate, to calculate the resistivity of water. There is a complete calculation and workflow and equations involved in that in the manually, but software will calculate on its own. We just have to provide the parameters. So there we will use the temperature and SP method. So we'll go to pre-computation, and there is a multiple method, RW method, temperature and salinity. If I have a salinity, I can use that. So but I will use the water resistivity from temperature and spontaneous potential, or SP. Okay, I'll click on that. There is our workflow. So I'll go to LQC, just double click on that to remove the curves. Okay, now go to SP log. It needs SP, so I click on that and then click on SP, and now next thing, click on formation temperature and temperature. Now it's saying mud filtrate resistivity or mud temperature in curve format. I don't have curve, so I will click on the create that and manually put the values of these. So I'll click on create and then click zones. I'll use all the zones, then click on the parameters. Now there is the important thing. Now it's asking us what is the mud filtrate resistivity and what is the mud temperature on that. So we will use the mud filtrate resistivity of for the bottom hole. So the RMF, the resistivity of mud filtrate at the bottom hole, is 0.196. So let me copy this from there and paste there. Okay, now it's saying the mud temperature. What is the temperature? Temperature is 208 degree Fahrenheit. So I click on 208 degree Fahrenheit. So there is our parameters that we needed. So just simply display. So let's see. So here you can see there is our RW curve, and it also calculated the salinity from SP and temperature. If you want to know about all the process behind this method, you simply have to click on this question mark and click on the help center, and you have to wait a little bit to let it open, and there you go. So here you can click on RW and click search. There is your resistivity from temperature and potential, and there it will show you what you need, like this. back, what will its output? You see our output, and these are all the equations that have been run in this process, but the software is doing this work for us, so we don't need to memorize these charts are also used in that, like this chart, the SP1 chart, the SP2 chart, and the Gantt 6 chart. When we use the manual calculation, we used all these, but the software make it easier for us, so we use the software. So let's close this. At any point you need any help, you just open this and it will tell you the detail. So here you can see, let me close this. I don't want to save this layout, so I click on no. So I want to save the RW value, so I go to save, and there you go, the RW and salinity is saved. So that's it for today's lecture. In the next lecture, we are going to do the complete petrophysics on that well. We will calculate the shale volume, we will calculate the porosity, then we will calculate the water saturation, and then we will mark our pay zone in that. So till then, take care and goodbye. Welcome to Techlog Fundamental Training Part 2. Today we are going to start the petrophysical interpretation. So in the last lecture we have computed some pre-computations like the temperature and the RW, which will be used in the further petrophysical analysis. So let's start the analysis. So let's start with the shale volume calculation. So for that you have to go to the petrophysics tab, then you have to go to the quantity, then you have to go to the shale volume. So there are multiple methods by which you can calculate the shale volume, but most common and most used method is a GR method. So we will use the GR method, but we will also show you some other method that how we can calculate the shale volume. So let's start with the GR, the gamma ray. So let's click the log. Now here's the window for input data. So we have to double click on that to remove the GR. So we have to select the log QC that we have created in the last video, the LQC. Then click that variable and we need GR, so click the GR and then click on the gamma ray and press create. Okay, there is our workflow manager, and there is our workflow of shale gamma ray. So well is SGS, our data set is LQC and is GR. So now we have to add our zones. So here we can take the whole well as a one zone. Like there you can see the all from top to bottom. But in the nature, the every formation and the every rock having the differentiate shale volume. So we have to select the zone. So for that we have to go to zonation tab, then we have to click on the zonation, and here we go. All our formation. So let's select our formations like 1 2 3 4 5 6 7, and we have to click on this option. Like you see the 3 bar color and the arrow option. When you click on that, it will drag all the selected zone into this window. So let me select that, and here you go. You see, now here you see the top of the A shale will be 17.1 and bottom is this 601.3785, and same will goes to every formation. Now let's set the shale volume parameter. So let's go to the parameter tabs. Now by default the GR matrix will be 10 and GR shale will be 100. It's a by default value, and the method is a linear. There is a multiple methods that can be used for the GR, the shale volume calculation, the V shale calculation. If you want to detail of all these methods, you can click on the question mark or help and go to the help center. You have to wait a minute to let the help center open, and here we go. Now see, there is all the detail of the methods that we can use to calculate the V shale. Like you say, we need input, the gamma ray log, we need the parameters, the gamma ray log reading 100% matrix or 100% shale, and methods. So here you can see the volume of shale, its units, index, its equations. Like these are the equations used to calculate the shale volume. Like in linear method, V shale is calculated from GR index, and this is the GR index formula. Then Clavier method and all the different methods, and you can see their detail if you want to. So let's move to our workflow manager. So we can manually add the values of GR matrix or GR shale like this, but today we are going to tell you how to visually set these values, like the shale baseline and the sand baseline. So for that you have to click on the display current layout parameter, and then you have to click on the layouts of input, and let's see, then play on the run. And where is our, the layout is not opening. Let me see again. Let's click on the layout, and here we go. Now layout is open. So there are multiple scales. You can vertically adjust. Click on that, it will show the complete well, but it's not visible. We can horizontally adjust. When we click on that, it adjusts that horizontally. We can global adjust, or we can one by one. Now you see our GR, but lines are not visible, so we have to close this. Don't save. So let's again click on the display and let me see. There is some issue with the display. It's not showing. And let's see. No. So let me close this workflow, and I don't want to save this, so I close it. And I also want to close this layout. I already saved in previous lecture, so I'm not gonna save this. And now I will go to petrophysics, go to shell volume, the gamma ray. Again, just remove this LQC, the gamma ray, select, create, and now it will work. Okay, so it's saying please drop your dataset here. So I have to go to the well SGS1, expand, and our data is LQC SGS1, so I'll drop it here. So now this is asking for zone, so I'll go to the zone and let me select the zonation and select all the zones, and by clicking on this icon I'm gonna drop all the zone here. So now go to the parameters and let's select the parameter and click on display. And now here you can see there is the shale baseline and the geometrics are sand baseline. So we can manually define that. Let's do that. Let me set the scale a little bit bigger so we can see our log. So for that you have to click the control and move the cursor, move the wheel of your mouse and scale it down. And now here you can see our logs. Okay, now let's set up our log and let's see, this is our sand baseline and this is our sand, so let's move it there. There's no clear shale in there. This is 75 cutoff, so let's keep it on 100. Let's move to the limestone. It's a limestone formation. This here it is clean, and there is a little stringer of a shale. Let's zoom it, control and mouse scroll, and let's set this at maximum shale. So now again the little formation, so let's again click on the, press the control and mouse scroll and set the clean value, and we can set our shale up down there. That is good. Let's again, it's a larger zone now, so I have to change my scale. So here we go, there we go, more, and there we go. So there is our maximum shale peaks. So I have to set the shale baseline to that peak, and where the cleanest sand there will be. formation. So again I have to change my scale so I can see it clearly. So see, there are our maximum values and there are our, there we go, maximum sand. And here we go. Now let's again change. This maximum sand is here up, so I have to move a little bit and move this a little bit too. And again, this is the last formation. So click here, let's move this down there, and done. Let's close this layout. It will automatically fill out the workflows parameter, so we just have to close this, and we don't need to save this. So no, you can save this for yourself, but we don't need this because we have set all the values. Or if we want to this window show again, we can just click on the run and it will show again with the same parameter. So just click no, and now here you can see the GR matrix value automatically filled down there, and GR share value also. So we have created our share volume parameters, so we just have to save and run, save and display. So just click on save and display. So here we go, and this, just have to check it. Okay, it's fine, and it's good. So we just have to close it and don't save. So let's check in our data set LQC, and here you can see the shale volume curve. We have generated a new shale volume curve here. So in the same way we can calculate the shale volume from the different methods. Like let's try another method like a combined method. So we have to click the shale volume. So there it wants the multiple curves. So let's remove these all. So let's select this, and first we need GR, so we drop down GR. We don't have thorium, potassium, we have SP, so we will give it SP. It need resistivity, so we'll give it a deep resistivity. Then it need neutron porosity, this is N5. Then it need bulk density, which is rho B, and then it needs compressional slowness as DT. So we click on that, and here you can see. So here we have to define all the parameters like these. This is asking us which parameter you want to use. Do you want to use GR or not, water resistivity or not, neutron density or not, SP or not. So I want to select all these. Then there is a GR, it's automatically pick the values from last calculation. Then there is SP, then there is resistivity, neutron density, and then final it will be use the method. Okay, so let's just display this, and here you will see all the thing. Now see, there is a shale volume from GR, this is a shale volume from SP, this is a shale volume from resistivity, and this shell volume from neutron density. Now see, our neutron density and GR are following each other. They're almost the same. So we can set these parameters, but we don't need to. The GR shell volume is more than enough for us. So just have to close this. No. So I don't need to save this. I just want to show you there is another method too, but it is advanced. So you keep only GR method there. So let's move to the next step. Now let's calculate the porosities. So again, go to the quantity, go to the porosity and saturation. So click on that. Now go to the porosity option. So there are again the multiple options: the total porosity from neutron density, neutron sonic, density, sonic, shear sonic, then effective porosity from neutron density, neutron sonic, density, sonic, and other methods. So if we calculate the total porosity, it will calculate only the total porosity. But if we calculate the effective porosity, it will calculate total porosity and then calculate the effective porosity. Mean in effective porosity method, it will calculate the both porosities in a one go. So we will use this method. So first we will use the neutron density method. So let's click on that and let's move these curves and go to the dataset LQC. Now it needs neutron porosity, click N5 and then click neutron porosity. Then it's a bulk density, which is rho B. So click on this and click bulk density. So now it's saying shell volumes. Click V shell and shell volume. Now you see in the workflow, on the interpretation workflow, for the porosity calculation we need the shell volume. So that's why we calculated the shell volume first. So we have given the values. Now let's click on create. Okay, there is our parameter window. So we have to click on zones, then we have to click the parameters. So now you see all the formation, there are parameters which is automatically picked by the Techlog. You simply just have to run the process and it will calculate the porosities. In the back end, it has the multiple equation that it will use. So let's click on display, and here we go. Now we will see how the porosities change with the formations. So let's move little a bit. Okay, now see. So phi E mean effective porosity and D mean is a neutron density. Phi T is a total porosity and D is neutron density. Okay, let's see. Because it's a shell, so total porosity will be very high, but don't have a good effective porosity. Now this is our zone of interest. You see the neutron density crossover is here, and you can see the good porosity over there. Let me show you. Let's click on this to display value and display line position, and here you can see you have a total porosity at that point is 28%, and your effective porosity is 23%. So this is a very good porosity. And see where there is a 2% effective porosity because there is a shear volume high, the higher shear volume. So let's move down a little bit. See this zone with the crossover present, you will see the good porosity. So this is effective, this is total porosity. You see I select this, and so that one is total porosity, and this is the effective porosity. The total porosity will always be higher than the effective porosity because the effective porosity is calculated using the V shell. When we minus the V shell from the total porosity, V shell means the shell volume. When we minus the shell volume from the total porosity, it will give us the effective porosity. Okay, let's move down, and you can see the porosity changes. So there you can see the log is out of range, so we can see the abnormality in the porosity. See this. So where the density logs are not correct, we can use the sonic log for the porosity calculation. See there is logs are correct, then we can see the correct porosities. Now see, there we go. But we don't have any crossover here, and there is very high shell volume, and there's total porosity about 20%, but no effective porosity because it's a shell. Let's see any shear and sand formation with the crossover. Okay, let's go move down, 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 down. And here we go. See, this yellow color is a crossover, and as you see, the crossover is present where the shell volume is the minimum. If there is shell volume high, it means it's a shell, and shell is not our reservoir. Our reservoir is a sandstone or limestone or dolomite. So see, when V shell is down, that means this is our sandstone reservoir, and it also have good porosities. See, the effective porosity is 16% and 12%, 10%. It's also a good zone. And see, there we go. And again, where shell volume increase, our effective porosity almost zero. See again, there is 1, 0 to 1. 0 mean minimum, 1 mean 100%. Same for the porosity. 0.3 means 0 to 30%. So now let me see. There is few patches which having good porosity, but this is 6%, and again there is no porosity down there. So this is the neutron density method of porosity calculation. So let's close this and don't save this, but we have to save the curves. So we have to click on the save, and here we go. We have a 5e neutron density, the effective porosity, and 5t neutron density, the total porosity. Now we will calculate the porosity from the sonic log, because we see that at some point our density log is not valid. If our hole is not gauged, then the density log is not reliable, because the density log is acquired with the help of a padded tool. The tool runs with the whole surface. There must not be any space between the tool and the formation. If our hole is caved, then there is a gap between the tool and our formation. Then there must be mud between the tool and the formation, so it affects the value of density log. So in that condition, we will use the sonic log to calculate the porosity. So for that, we go to porosity, and we go to effective porosity and click the sonic. So we'll go to our LQC, click the sonic, which is a DT. So click on that. When we lay the shell volume, so we will click on V shell, and there we go. It's our V shell, and we click on create, and we have to check our zone. All zones are present. We have to check the parameter. Take this parameter by default. There are also multiple methods for sonic to calculate the porosity. You can use any and compare them. So let me display the porosity. So let me check the one. Zoom out, and let's go down, and let me see. And here you can see again the same situation. In the where the shear volume is high, we have high total porosity. So here we go. In the limestone, you can see it's showing very good porosity, and also our neutron density is showing the good porosity in that zone. See? Okay, let's move down. The sonic is showing very high porosities, but in that zone, let's move down a little bit. You can see again, you can see the high shell volume, the high total porosity, and low effective porosity. Again, same. Okay, we will also save. We don't have to save the layout, we only have to save the curves. So click on save, and you see the phi is the sonic, the phi t is the total porosity. So let's go to porosity and click on final, and we have to go to LQC and click the neutron density and sonic porosity. We have to create zone parameters it will create a final curve for us. So let's display the curve. It will average out both the curves, and here we go. Here you can see there is the average curve of neutron and sonic. So it's our corrected porosities. So we will use the final porosities for our calculations. You see, sonic having very high porosities, but neutron density having little low, so it's averaged out. These porosities are very high due to the incorrect logs, so we don't have to consider that. These are our desired porosities or desired zones. Okay, let's close this. Don't save the layout. Let's save the porosity, and here we go. We have a final porosity. Okay, let's move to the next and most important step, where we will find out which zone contains the hydrocarbon. So for that we have to go to the quantity, the situation, porosity and saturation, and we have to go to situation, and there is a multiple methods to calculate the water saturation, but we will use the Archie's, which is the most famous method to calculate the water saturation. So let's click the Archie's and let's fill out the parameters. So click on the LQC. Now need the formation resistivity, which is the deep resistivity, which is LLD. So click on the formation resistivity and send it to there. Then we need a porosity. We will use the 5 final, the total porosity, and it needs the formation water resistivity, RW, which we already had created in the first lecture. So click on that and click the formation water resistivity and create. Okay, there we can see all the parameters. Now click on zones. All zones are there. Let's see the parameters, and by default the AMN, the cementation factors, are by default added. Now just really simple, just click the run and it will calculate the water saturation. So let's click on that and let's change the scale to 500 and let's move down. Let's move down a little bit, and here we go. You see, this is our saturation SW from RG, 0 to 1. The 1 mean is 100% water saturation. The 0 mean is 0% water saturation. 0 mean 100% hydrocarbon saturation, and this 1 mean 0% hydrocarbon saturation. So as long as our water saturation is less than around 60%, we having the good hydrocarbon in that zone. So let's check out our zones. So let's click on the value and the line, and now see, here we go. At this zone we having 17% porosity, which is very good, and we having 16% water saturation. It's excellent, because 16% water saturation mean we have 84% hydrocarbon saturation. So it's mean that this zone contain the really good hydrocarbons. Okay, let's move down there. See, up to 60% it's a good. There's a 70%, it's mean there's a water. But again it's a little stringer. Again it's drop down. It's all the hydrocarbons. So this zone, you see the depth, there is a depth. It starts from 608 to down to 642. It's around 30-meter bed with a very good hydrocarbon saturation. So our calculations shows that we can test these zones like this and this. Let's move down. There is a high water saturation. Again this is 60 plus, 60 plus. This is 100% water. Again move down, this 100% water down there. Now again it's all water. We having another zone in the lower portion where we have good porosity that we have checked in the neutron density, where we found the crossover. So let's check those zones. So here are those zones. In the formation D we have good porosity up to 50%, but this is water wet. You see 19.96, almost 100% water. It's 100% water. The 79 is all water. All the blue shade is showing it's water. So it's mean this is not a good zone. We don't need to test that zone. So our zone of interest is the upper portion. This, the formation A, the limestone. That zone from 608.5 to we can test that 623, and then we having 627 to almost there 644. This is our zone of interest. So let's save this and display it in a better way. So let's close this. I don't want to save this layout, I just want this, and I want to save our water saturation, and there is our water saturation. Now let's make a new layout. Let me minimize this and go to the home tab, go to the plot tab and click the log view and open this. Now first of all I want to display my V shape. Okay, now next I want to show my total porosity. So I will click the effective porosity. Here is my porosity, and next I want to set my water saturation, and here we go. And now I also want to set my zones. So I right click on empty space and click the new zonation track, click on this, and let's turn on the zones, and here we go. See, this is not good zone. This is our zone where you can see very low share. It's a good reservoir. and see here's a very good processes. Average is ranging from 23 to 20, and see, look at that, our water saturation very low. Let's see, here we go. This top zone is our zone of interest. There is all water below that. See, so this is the only zone of interest for us, so let's only display that. Let's zoom this out by clicking mouse scroll button and zoom this out. So I want to display only this FMA limestone, so I have to click on there on empty space, then go to property and the reference limitation, so click on limitation. So I want the top zone must be the formation A limestone and the bottom zone also the formation A limestone. The delta mean how much I want above that zone. I don't want above anything that zone, but only want to show you I want 10 meter delta above. So when I click on tell, it will show 10 meter of above that zone. Okay, you see, we now only have our zone of interest there. I also want to move this to back end, so I have to click on this track and let's move to there. You see, there we can move that anywhere by left right button. We can move the curves in that fashion too. Like I select this curve and I can move this to the there. It's very easy. Okay, that's our zone of interest. Now let's Now let's apply the final cutoffs on this. So let's display our whole well again. So let's remove the limitation by going to properties. So there is our all well. Okay, now apply our cutoffs like shale volume cutoff, the porosity cutoff and the water saturation cutoff. So for that we have to go to petrophysics, we have to go to the summaries, and we will go to the again the summaries. I will click on the summaries. So we have to give the parameters. We have to LQC, we need the shale volume, we click on that and shale volume, we need the porosity, we will take 5 final porosity, then we need the water saturation, there is our SW, the water saturation, the RC, we'll click on that and let's create. Where you go, let me see our workflow. No, there is no where. Let me close this layout. We can save this, and let me save this with the name of final and click OK. Let's close this too, because we already did that. We can save this. Save. Yes, you can give any name to that, like I say SGS, and save our project manager. So now again I go to the quantity and go to summary and click on summaries, and here we go, summaries are open. I have to select again shell volume, which is shell volume, final porosity, and again I have water saturation. Where is water saturation? SW. There is our water saturation, and click on create, and there we go. There is our workflow, the new workflow of summaries. So it says please drop your data set. So again we have to go to the project browser, and here we having our summaries. Now our dataset, which is LQC, so let's drop it there. Now it needs zones, which zone we want to use to calculate, to set our cutoffs. So as we see, we have the only zone of interest, which is, and we go to zone, which is the formation A limestone. So we only click on that. We can use all other for cutoffs, but we will use only this limestone. Click on that, and we move that into there. Okay, now we have to set the parameters. Let's maximize this. Okay, in the parameter, first the shell volume, the minimum shell volume will be 0. The maximum shell volume we take the 0.5 mean the 50%. Like, so let me tell you what it's mean. It's mean it will take that portion of the rock which having the shell volume 0 to 50%. It will not take that rock which having shell volume greater than 50%. Okay, if the shell volume is greater than 50%, it will not qualify for the reservoir rock. So we put the cutoff. We can change that. In some zones up to 65% shell volume, the rock can act as a reservoir, but we are using the 50% for your understanding. So now porosity cutoff. Now here the minimum is 0 and maximum is 5%, but no, the 0 porosity will never produce. Our reservoir is a limestone, so we will take the minimum 4% porosity. So in decimal it will be 0.04. So it means it will not take any part of the rock which having porosity less than 4%, and maximum 50%. 50% is too high. We will take that about like we can say that 30% cutoff, 0.3. It will not take those rock which having more than 30% porosity. Okay, now the final thing. The minimum water saturation is 0% is good. 0% is the hydrocarbon. The maximum saturation, there it put the 85%. No, it's too high. If the formation have 80%, 85% water saturation, it means it's all water. We need the maximum 60%. Maximum 60%, not more than 60%. so we take the 60, so it will take 0 to 60. So now flags. Now for the rock, first we will separate out the rock, either is a shale or either is a sand or limestone. So for the rock we will only use the shale volume cutoff. So we click the yes on the shale and no for porosity and water saturation. Now the reservoir, as you know, the reservoir property is porosity permeability. So for that, first we apply the shale volume cutoff. It will separate the shale from sand and limestone. Then we will put the porosity, so it will extract all those beds which having the porosity range that we have defined, like 4% to 30%. So in the last is a pay zone that we can produce. So there we will apply all the three cutoff. The first, we remove the shale from the rock, then we will separate out all those beds which having porosity ranging from 4 to 30%, and then from that reservoir which having porosity 4 to 30%, we will select the zone which having hydrocarbon saturation about minimum 40%, like the water saturation from 0 to maximum 60%. So that will be our pay zone. So we set all our flags. So see result, there is no result, we have to run this. So we have to first display it. So click on this, and here you can see this is our shale volume, this is then again our porosity, and this is the water saturation. As I told you, these are the good zones. So now it's time for the cutoffs. Though this is the first cutoff of shale volume, so it select all this zone. You see all this zone having shale volume less than 50%. You see this is all the first column. The second column is a reservoir cutoff. It will take all the rock which having less than 30%, greater than 4% porosity. Now see, at that zone, this empty zone is not taken the zone. Why? Because it's showing 100% porosity. In nature, this is impossible. So it's incorrect. So it's not counted there. And that zone, you see 3%, 4%, because this is less than 4%, so it was not counted. And see again there, the 100% porosity, it say no, it's not possible in nature. There's a less porosity, 3%, so it hasn't taken that. And now you see at that zone we have a shale volume grade almost 90%. So at that shale volume cutoff, this zone is not taken. Now next, our water saturation cutoff. Now see, the water saturation cutoff is maximum 60%. So in that zone, you can see it is selected because it having a good hydrocarbon saturation in this whole bed. See, this is the 16-meter bed, this pay zone. See, these are the result of the cutoffs. We'll show you. Now at that zone, we having greater than 16% water saturation, so it excluded that zone. Same in this case. Same this. Now these are the results. The rock thickness, this is total 114 meter thick bed, which having the shale volume less than 50%. Then when we use the porosity cutter, it will remain about 68 meter. Okay, and then when we apply the water saturation cutter, then we have one 16 meter bed and the other 17 meter bed. So these two are our pay zone, and they are having a good porosity, about average porosity 22 and that, and good hydrocarbon saturation around 60 to 20. So this is our final layout that every company use and most students use in their thesis. So we have to save this. So let's click on this multi-well layout option and just save and click save, and yes, and let's click save. Save all the variables. It will save all the flags that are used in there. So just click apply to all and click OK. And now it's asking for layout. So let's give him any name. So let's see. There's workout save, workflow save. So now go to quantitative results. Just minimize this and go to the results in MD. So here we go. There we go. You see we have total 136.772 meter bed with the shear volume cutoff, then the reservoir is 115, and the pay zone remain only 38 meter. You can see net the gross ratio also here. You will also see there is the average shale volume, there you can see, and you see average porosity. In the pay zone you can see the average porosity is 19%, and the average water saturation is around 30%. That's a very good hydrocarbon bearing formation. So these are our results, and this is also the final product. You can just select this like this, copy this, and you can go to the Excel and just